this is the last type of acid derivatives that we're gonna look at are nitriles, and the reason why this is sort of set apart from the other acid derivatives, you know, for example, the acid chloride, anhydride, esters, and amides, is that it is a little bit different type of chemistry. We're just going to go over the most important reactions with the nitriles, but it does belong in the acid derivatives just because it has the oxidation level of 3. So the nitriles are the ones with a C triple bond N group attached to a group, and the way you would name these is that you would replace the ic or the oic acid with O-nitrile. All right, so for example, if you have a CH3CN, then this would be the derivative of CH3CO2H, right? So this is called acetic acid, that's the common name, or ethanoic acid. So then you would drop the ic acid and then replace with the O-nitrile, so it would be acetonitrile. And the other example is if you have, for example, this compound, then this is benzonitrile. Alright, so it should be pretty simple to name these. And then for the preparation of nitriles, this first one should be a review for you, in that you're doing a substitution SN2 displacement of an alkyl halide with the cyanide ion. So remember from Chem 114, if you have, so it's a SN2 type of reaction, if you have a primary or the best alkyl halides, and then you're reacting with cyanide ion, so potassium or sodium anion. This is a nucleophilic carbon. It's going to go and do a nucleophilic displacement. So then you have 1, 2, 3, 4, 1, 2, 3, 4, and you have at the 5th carbon a nitrile displacing the bromide. 1, 2, 3, 4, 5, right? So this would be 1, 2, 3, 4, 5 carbon long, just like before, with the nitrile at the end that has done the displacement. All right. So that should be a total review. And then the second way to make nitrile would be dehydrating the amide. So you would start out with whatever amide that you want to convert it to nitrile. And remember the thionyl chloride reagent that we used to convert carboxylic acid to the acid chloride. Use the same reagent, and it dehydrates the amide. So basically, essentially, you're getting rid of H2O. From the amide, and then you get a nitrile out of that. So that's a neither oxidation nor reduction, because this carbon right here is oxidation level 3 here, and you're still at oxidation level 3. So you're just taking out water from the starting material. So those are the most common ways to make nitriles. And then why are nitriles useful for synthesis? What can you do with nitriles, right? So like the other reactions that we've seen, you could take nitriles and you could convert to carboxylic acid. So the hydrolysis, you could do it both under acidic conditions or basic conditions. So in both cases, the hydrolysis will basically you're substituting water to the nitrile. So it's an easy way to get to carboxylic acid. All right. The intermediate is an amide initially, and then the amide, as you know, can be hydrolyzed to carboxylic acid. And the mechanism of the both acid catalyzed and the base catalyzed hydrolysis is shown in your book in page 1012. If you are curious as to what the mechanism is, you're welcome to take a look at it. It follows basically the same sequence of events that you've seen over and over again. I'm not going to have you be responsible for it other than to know this transformation. All right. The second one is reduction of nitriles, and once again, this is sort of same as we've seen with the other acid derivatives. You could take lithium aluminum hydride and you could convert to the amine as shown with amides before. So same condition. To get to the amine, you're basically reducing the carbon from the triple bond, oxygen level 3 to oxygen level 1. Alright, and then the last reaction that we're going to look at is the Grignard reaction with nitriles. And in this, you're basically taking the Grignard reagent, MgBr, and this is going to be a nucleophilic attack to the nitrile, and you initially get like an imidate ion, and this is the intermediate. So this right here, if you just protonate that, you're getting an imine out of it, and imines could be easily hydrolyzed. Imines could be easily hydrolyzed to ketone. So this is a good way to get to a ketone stage after reacting with the Grignard reagent, because as you know, the other acid derivatives is hard to stop at the ketone stage, because what you get usually is a ketone as the intermediate, so then the Grignard reagent reacts again to attach two equivalents of Grignard reagent usually, but here when you start with the nitrile, you could stop at the ketone stage. All right. So these are the reactions that I'm holding you responsible for. So you have the how to prepare the nitriles, as well as the 3 reactions of nitriles, so that you could use all this in your synthesis, which is what we're going to go over next. All right, so that concludes all the reactions for the acid derivatives.